Article 110.54b addresses equipment grounding conductors. When dealing with full conductor armored cable, several options exist for providing an equipment grounding conductor. Firstly, you can use the armor as the equipment grounding conductor if it meets the requirements outlined in Section 250.118 of the National Electrical Code. This typically involves ensuring that the armor is of a stranded type and possesses an adequate cross-sectional area based on both the size of the cable and the insulation type utilized. Secondly, you have the option to run a separate, bare copper conductor alongside the cable to serve as the equipment grounding conductor. This approach is valid if the cable's armor cannot be utilized as the equipment grounding conductor. However, it necessitates installing an additional conductor and ensuring it's properly connected. Thirdly, consider situations where the cable lacks armor altogether or the existing armor is deemed unsuitable for use as an equipment grounding conductor. In a separately derived system, it is mandatory to run a separate equipment grounding conductor with a cross-sectional area that matches the largest circuit conductor. In a non-separately derived system, you are permitted to utilize a smaller equipment grounding conductor, even as small as a WG12, provided it is sufficiently bonded to the service equipment. It is critical to note that in a non-separately derived system, the practice of running a bare copper conductor alongside the cable is not permissible. When utilizing the armor as the equipment grounding conductor, twisting the armor strands together and connecting them to the ground bus is generally considered an acceptable bonding method. However, any cut-off strand should be properly terminated to eliminate any sharp edges that could pose a hazard. When opting to run a separate bare copper equipment grounding conductor, it is imperative that its cross-sectional area is sized in accordance with Section 250.122 of the National Electrical Code. Additionally, the equipment grounding conductor must be correctly connected to the equipment grounding terminal of the panel board as well as to the bonding jumper located at the service equipment. Ultimately, the most suitable approach depends on the specific circumstances of the installation and local interpretations of the code. It is highly recommended to consult with the local electrical inspector to ensure compliance and receive guidance tailored to the project. The code addresses conductor requirements, including equipment grounding conductors. Specifically, concerning the scenario with 4-conductor armored cable, it's important to address several points. If the 4-conductor armored cable contains an armor that meets the requirements of Section 250.118 of the National Electrical Code, then the armor can be used as the equipment grounding conductor. These requirements typically dictate that the armor is of a stranded construction and has adequate cross-sectional area (CSA) based on the size and insulation type of the cable. In this situation, the armor serves as the dedicated path for fault current, providing a low impedance path back to the source. Alternatively, if the armor does not meet the requirements or it is preferred, a bare copper conductor can be run alongside the cable and used as the equipment grounding conductor. This is a viable option, especially if the armor is not suitable for grounding purposes. It is important to note that the bare copper conductor must be properly sized and connected to the grounding system. If the cable lacks armor entirely, or the armor cannot be used as the equipment grounding conductor, then a separate equipment grounding conductor is required. In this case, with a 4-conductor cable comprising 3-phase conductors and a neutral conductor, there would not be an equipment grounding conductor within the cable assembly itself. Therefore, a separate equipment grounding conductor must be installed. For separately derived systems, a separate equipment grounding conductor must be run with the circuit conductors, and its size should be based on the size of the largest and rounded conductor, as specified in Section 250.122. For non-separately derived systems, the requirements for the equipment grounding conductor may differ. While a separate equipment grounding conductor is still necessary, its size can be determined based on Table 250.122, which allows for smaller sizes in some cases, provided certain conditions are met. However, in no instance should a bare copper conductor be run separately in a non-separately derived system. Regarding the practice of twisting the stranded steel armor together and connecting it to the ground bus, it's important to ensure that the connection is mechanically sound and provides a reliable electrical path. While this method may be acceptable, it's crucial to properly terminate the unused strands to prevent them from becoming a hazard. Preferring to run a separate bare copper cable for proper sizing is understandable, as it allows for precise control over the equipment grounding conductor's ampacity. However, code compliance is paramount and local interpretations may vary. Therefore, consulting with the local electrical inspector is advisable to ensure that the chosen method meets the requirements. In summary, when dealing with 4-conductor armored cable, the armor can be used as the equipment grounding conductor if it meets the requirements of section 250.118. Alternatively, a bare copper conductor can be run alongside the cable, but only under specific circumstances. If the cable lacks armor or the armor is unsuitable, a separate equipment grounding conductor is required, with sizing determined by section 250.122. It is also important to remember the differences in requirements for separately derived systems and non-separately derived systems. Always consult with the local electrical inspector to ensure compliance with the code and proper grounding practices. The original question involves interpreting Article 110.54b of an unspecified code, presumably the National Electrical Code, NEC, regarding equipment grounding conductors X in relation to 4-conductor armored cable. There are several aspects to consider. Firstly, whether the armor of the 4-conductor armored cable can be used as an equipment grounding conductor. Secondly, whether a bare copper conductor can be run alongside the cable and used as the equipment grounding conductor. Thirdly, what to do if the cable has no armor or the armor cannot be used as an equipment grounding conductor. The NEC addresses these issues in various sections. If the 4-conductor armored cable has an armor that meets the requirements of section 250.118, then the armor can be used as the equipment grounding conductor. Section 250.118 specifies the types of equipment grounding conductors and equipment bonding jumpers that are acceptable for use. These include metal raceways, cable trays, metal armor of cables, other metal enclosures, and conductors. If the armor of the 4-conductor armored cable is listed and identified for grounding, and it meets the other requirements of section 250.118, then it can be used as the equipment grounding conductor. If the armor of the 4-conductor armored cable does not meet the requirements of section 250.118, then it cannot be used as the equipment grounding conductor. In this case, an equipment grounding conductor must be run with the circuit conductors inside the metal raceway or multi-conductor cable jacket, as required by Article 110.54b. Running a bare copper conductor alongside the cable and using that as the equipment grounding conductor is not permitted by the NEC. Section 300.3b requires that all conductors of a circuit, including the equipment grounding conductor, be installed in the same raceway, cable, or enclosure. This is to ensure that the impedance of the circuit is low and that ground faults are cleared quickly. Running a bare copper conductor alongside the cable would increase the impedance of the circuit and could delay the clearing of ground faults. If the cable has no armor or the armor cannot be used as an equipment grounding conductor, then an equipment grounding conductor must be run with the circuit conductors inside the metal raceway or multi-conductor cable jacket, as required by Article 110.54b. In the case of a 4-conductor cable with 3 conductors and a grounded conductor, there would be no equipment grounding conductor within the cable itself. Therefore, an equipment grounding conductor would have to be run separately. The equipment grounding conductor must be sized in accordance with Section 250.122. Section 250.122 provides tables that specify the minimum size of equipment grounding conductors for various circuit sizes. The size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. The fact that the service is always an underground feed and usually 4-conductor armored cable is not relevant to the requirements for equipment grounding conductors. The requirements for equipment grounding conductors are the same regardless of whether the service is underground or overhead. The fact that the armor is stranded steel and is being twisted together and connected to the ground bus is also not relevant to the requirements for equipment grounding conductors. The NEC does not specify how equipment grounding conductors must be connected to the ground bus. However, the connection must be mechanically sound and provide a low impedance path to ground. Cutting off the unused strands is acceptable as long as the remaining strands provide a sufficient connection to the ground bus. However, it is important to ensure that the cut-off strands are properly terminated to prevent them from becoming a hazard. The preference to run a separate bare copper cable is understandable, as it allows for proper sizing without having to guess how many steel strands to twist together. However, the NEC does not allow this. The NEC requires that all conductors of a circuit, including the equipment grounding conductor, be installed in the same raceway, cable, or enclosure. In summary, the NEC requires that an equipment grounding conductor be run with the circuit conductors inside a metal raceway or multi-conductor cable jacket. The armor of the 4-conductor armored cable can be used as the equipment grounding conductor if it meets the requirements of section 250.118. A bare copper conductor cannot be run alongside the cable and used as the equipment grounding conductor. If the cable has no armor or the armor cannot be used as an equipment grounding conductor, then an equipment grounding conductor must be run separately. The equipment grounding conductor must be sized in accordance with section 250.122. It is always recommended to consult with the local electrical inspector for guidance on specific installations. The original question pertains to the application of Article 110.54b concerning equipment grounding conductors X within metal raceways or multi-conductor cables, specifically in the context of 4-conductor armored cable. Let's break down the key points and address the inquiries. Firstly, the question of whether the armor of the 4-conductor armored cable can be used as an equipment grounding conductor is addressed in section 250.118 of the National Electrical Code (NEC). This section outlines the acceptable types of equipment grounding conductors and equipment bonding jumpers. According to this section, the metal armor of cables, including armored cable, is indeed permitted to serve as an equipment grounding conductor, provided it meets certain conditions. These conditions typically include that the armor is identified for grounding purposes, is mechanically and electrically continuous, and has adequate ampacity to safely conduct fault current. Secondly, the question of whether a bare copper conductor can be run alongside the cable and used as an equipment grounding conductor requires careful consideration. While it might seem like a convenient solution for ensuring proper grounding, the NEC generally discourages this practice. Section 300.3b mandates that all conductors of a circuit, including the equipment grounding conductor, must be installed together in the same raceway, cable, or enclosure. This requirement aims to minimize impedance and inductive reactance, which can impede the flow of fault current and delay the operation of overcurrent protective devices. Running a bare copper conductor separately from the other circuit conductors violates this principle and could compromise the effectiveness of the grounding system. Thirdly, the question of what to do if the cable has no armor or the armor cannot be used as an equipment grounding conductor is pertinent. In such scenarios, the NEC requires that a separate equipment grounding conductor be installed alongside the circuit conductors within the same raceway or cable assembly. This equipment grounding conductor must be sized in accordance with section 250.122, which provides guidance on determining the appropriate size based on the rating of the overcurrent protective device protecting the circuit. The reference to separately derived systems (SDS) and non-separately derived systems adds another layer of complexity. In separately derived systems, the equipment grounding conductor must be sized based on the size of the largest ungrounded conductor, as per section 250.122. In non-separately derived systems, the requirements for equipment grounding conductors may differ slightly, but the fundamental principle of providing a low impedance path for fault current remains the same. Regarding the practice of twisting the armor strands together and connecting them to the ground bus, it's essential to ensure that the connection is mechanically sound and provides a reliable electrical path. While this method may be acceptable in some jurisdictions, it's crucial to verify that it complies with local codes and regulations. The unused strands should be properly terminated to prevent them from becoming a hazard. The preference to run a separate bare copper cable for proper sizing is understandable, but it's important to prioritize compliance with the NEC and local codes. Consulting with the local electrical inspector is always advisable to ensure that the chosen grounding method meets the requirements and provides adequate safety. To summarize, when dealing with 4-conductor armored cable, the armor can be used as an equipment grounding conductor if it meets the requirements of section 250.118. Running a bare copper conductor alongside the cable is generally discouraged, and a separate equipment grounding conductor should be installed within the same raceway or cable assembly if the armor is not suitable. The equipment grounding conductor must be sized in accordance with section 250.122, and local codes and regulations should be consulted to ensure compliance.